Hello everybody, welcome back to Math 1350, more on math. Today's section is Chapter 7, Section 2. Section 2 deals with operations on decimals. By the 5th grade, the students are supposed to be able to add, subtract, multiply, and divide decimals to the 100th location using concrete models or drawings and strategies based on place values. Properties of operations with addition and subtraction. The relationship between adding and subtracting relate to the strategies to a written method. And explain the reasoning. First, they have to be able to prove why they did what they did, adding, subtracting, multiplying, and dividing decimals. Adding and subtracting decimals, just line up the decimals. For example, 1.43 plus 6.2. So 1.43, 6.2, add them up. 3 plus 0 is 3. 4 plus 2 is 6. There's a decimal. 6 plus 1 is 7. Let's look at subtraction using the same logic. Again, look at the signs. 6 is bigger than 1, so the answer is negative. Put the bigger number on top and subtract the smaller from. Since the bottom number has a couple of decimal places, you have to fill at the top. 0 minus 3, you can't do it, so you got to borrow 1. 10 minus 3, 7. 1 minus 4, you can't do it, so you have to borrow 1. 11 minus 4 is 7. There's a decimal. 5 minus 1 is 4, so the answer is negative 4.77. That's adding, subtracting decimals. Multiplying decimals. Let's look at 1.43 times 6.2. I've always found out the easiest way of doing this is first step. Remove the decimals. So 1, 2. But keep track how many spaces you moved. So that's 143. with 2 spaces gone. 62. Because when you add these together, I have to put back 3 spaces. Now multiply these whole numbers. Multiply, then replace decimal. So we have 143 times 62. 2 times 3 is 6, 2 times 4 is 8, 2 times 1 is 2. 0. 6 times 3 is 18. 6 times 4 is 24, plus 1 is 25. 6 times 1 is 6, plus 2 is 8. Now add these. So it's 6, 8, 8, 16. 5 plus 2 is 7, plus 1 is 8, 8. But we have to put back 3 decimal places. 1, 2, 3. So it's 8.866. So that's the easiest way I found out of multiplying decimals. Let's do another one. Zero 0.02 times 0.013. 1, 2. I took away 2 decimal places there. 1, 2, 3. So I have to put back 5 decimal places. 2 times 13 is 26. Remember, the decimal's back at the end. I have to put back 5 spaces. 1, 2, 3, 4, 5. So there's a 0, there's 0, there's 0. So the answer is 0.30, 26. What if I had 1,000 times 3.6? Since this one has 0 at the end of it, for every decimal place that I move, I lose a 0. Basically, I'm taking away a 10. Because remember, each space is a tens. So now I have 100 times 36. I don't have to pay anything back because I borrowed it. So 36 times 1 is 36 with 2 zeros at the end. Yeah, so that's where you multiply them. Now, decimals have a lot of uses. Business uses them. We use them every day when we deal with money, because it always has 2 decimal places. But in physics, chemistry, engineering, they use something called scientific notation. Scientific notation has this form. No matter what number you have, the decimal place is always after the first non-zero number. So it's only one number, decimal, that times 10 to how many spaces you need. So for example, 230. The first non-zero is a 2, so I put a decimal behind it. Now, how many spaces did I move it? That's 10 to 2 spaces. If the exponent is non-negative, that means it belongs to a big number. If the exponent is negative, that means it'll be a small number. This number here can be written as 2.6 times 10 to the 1, 2, 3, 4, negative 4. Alright, so be very careful about that. So when you convert this, since this is a big number bigger than 0, then it has to have a positive exponent. Let's look at this. If I had 413, 682, That's 413,682,000. In scientific notation, be 4.13682. And I don't have to put the rest of the zeros. So how many spaces times 10? 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th. So from this location to the end is 8 spaces. How about 0.0000231? The first non-zero digit is 2, so put a decimal. Whatever's behind it is 31. 1, 2, 3, 4, 5 spaces. But since I had to move to the right, that means it came from a small number, a negative number. This negative doesn't mean the answer is negative, it just means that the decimal moves to the left that many spaces when I put it back. 83.7. So I want it to be 8.37. I moved it 1 space. Here's my answer. Negative 10 million. The negative doesn't change anything, so the number is still going to be negative 1.0 since there's the decimal place. 367. .34 times 10 to the negative 6. Is this scientific notation? No, because in order to be scientific notation, I have to have a 3.4. Now, I have to go to the right one. Whenever I move to the right, because originally I subtracted 1. So if you move to the right, subtract. Move to the left, add. So since I'm moving to the right 1 space, I had to subtract it from my current exponent. So the answer is 3.4 times 10 to the negative 7. Alright, so far so good. Let's convert to decimals. .84 times 10 to the negative 5. Since it's negative, I have to go to the left. So I have 6.84. I have to move 5 spaces to the left. 1, 2, 3, 4, 5. So it's 1, 2, 3, 4 zeros. So basically, whenever you have scientific notations, if you have a negative exponent, whatever this number is here, subtract 1, that tells you how many zeros you have in front. Because the first space has to be taken by that whole number. So there goes that 1, whatever's left goes there. 3.12 times 10 to the 7th. Again, I start off with point, so I move it 7 spaces. 1, 2, 3, 4, 5, 6, 7. Since I used 2 spaces there, 7 minus 2, there'll be 5 zeros. Negative 4.08 times 10 to the 4th. because it's a positive, I still have 1, 2. So I have 2 zeros behind it. I have to move 2 more spaces. And there's my answer. You can, but you don't have to put a .0 behind it. There's your answer. Dividing decimals. Remember how we did with multiplication? When we multiplied, we got rid of the decimals and then put it back at the end. But when you're dividing, let's make something easy here. 0.16 divided by 0.4. Oh, 0.04. To get rid of the decimals, 1, 2, I have to move it 2 spaces each. So basically, all I'm doing is I'm multiplying top and bottom by 100. Remember, the number of spaces moved is the number of zeros. So 16 times 0.16 times 100 is 16. 0.04 times 100 is 4. And there's your answer. Okay, what if we had 0.0016, 0.004? If they're not the same. To get rid of it, use the most spaces. So this is 1, 2, 3, 4 spaces I gotta move. So I gotta multiply top and bottom by 10,000. 4 zeros. So if I move 4 spaces, that becomes 16. But on the bottom, there's 1, 2, 3, 4. It becomes 40. Now we have 16 goes into 40. Does 40 go into 16? No, so I put a decimal. When I put a decimal there, in other words, I added a number on top of 0. So 40 goes into 160 4 times. The answer is 0.04. Alright, so go ahead and practice those, and I'll see you at the homework site.